Senior Manager at upGrad Education Power Limited. He has published more than 85 research manuscripts in various international and national journals and conferences. He has also presented papers in international and national conferences. Sir is a member of editorial board of various international journals related to the field of computer science and IT. He is currently pursuing PhD in computer science and engineering. Today, his topic of the day is cloud computing in manufacturing and scalability and collaboration. Over to you, sir.
Thank you so much, ma'am, for such a warm welcome and introduction. So just want to segregate this audience. Wanted to know like how many people are there from non-tech backgrounds. So can I have that data so that I can talk accordingly? Okay.
Sir, we have people from different backgrounds. They all
Right.
are, some are, yes, some are from management, some are from mechanical. They all are from different backgrounds.
Right. Okay. So just give me a few minutes. Let me share my screen and then we will start.
Sure, sir.
Okay, so my screen is visible to everyone. Yes. Yes or no?
Yes, sir.
Yes, sir.
Sure. Okay, then we can start. Uh, uh, okay, so let me give you brief about my profile. So I'm working in the domain of cloud computing since 2018. I was previously working with some of the universities where I was handling IT operations, and from there, this journey into cloud computing has been started. So, just wanted to know, like, how many of you are aware about cloud computing? Anyone who can give me an example? You can unmute yourself and speak up. Yes, anyone? Anyone from the audience? Am I audible? Hello. Hello.
Hello, yes, sir, you're audible.
Okay.
Yes,
So,
Sir, cloud computing, although I belong to mechanical engineering background, but a little bit I know about cloud computing. These are sort of services that are provided online for saving our data or something to be connected with the data itself. So, like storage or something, we have to save some softwares to operate it like through the internet like connection, if I'm not wrong.
okay, got it, got it. So I'm taking a very simple example. What if what is your right location, sir, right now?
Sir,
Yes,
Amritsar.
Amritsar. So let's see. Let's take an example. You have to come to let it be Chandigarh for one day, or maybe for 1 month. So how would you accommodate yourself over there? Like, will you take a home over there, or you will get something over like any hotel where you will pay on a daily basis or something? what would be your preference?
So definitely, I would prefer hotels.
Okay, so let me give you an example. Before the advent of cloud computing, what used to happen, if I had to publish a website, let's take an example. It is the website of your college. If I have to do it, I have to take separate servers, and those servers need to be deployed into my premises, and by using various services, I need to put that data about my organization. So basically in websites, what happens, we generally give our own information and display it to the users so that they can know about our services, right? So we used to deploy a server. We need to buy a server first, then we need to buy some platforms on which those server has to be deployed, like uh, physical infrastructure, then the operating system, and then some other things. But after the advent of cloud computing, this scenario has changed. What we did, we have started taking these services on rent. So it is just related to somewhat where you are going to Chandigarh for, let it be, for 1 week. So you are not going to purchase the entire house over there. You are going to a hotel, you are taking a room over there, and you are paying as per your capacity. So paying as per your capacity is the main feature of cloud computing. So coming to the outline of this lecture. So basically there are 5 segments. Out of those 5 segments, first segment would uh, focus upon, like, induction of cloud computing in manufacturing. So now I had designed this uh, basically lecture in such a way. I was thinking like people would be from computer science background. So before moving to manufacturing, let's discuss like what is cloud computing. So we will start talking about cloud computing in manufacturing. So first we will talk about the concept of manufacturing, then concept of cloud computing, then how we have admitted it into the manufacturing practices, what challenges we got, and then what are the benefits of using cloud computing in manufacturing practices. So let's start with the core concept first, like what is cloud computing. So as you can see on the screen, cloud computing is the mixture of two words. So just ignore the picture which is at your screen. Just focus upon these two words, cloud plus computing. So anyone from you who can tell me what exactly computing is? So let's forget about cloud. Let's talk about computing. What is computing? Yes, anyone from the audience, please. Yes. Hello. So, should I take names and then start talking to you, or you can take the initiative and talk to me bluntly? Yes.
Participants are requested to kindly make involved in this. Get yourself involved in the session, please.
Yes.
Sir, basically it is the use of computers to process the data or to perform calculations.
Exactly. Thank you so much, sir. So basically, computing is nothing but using computers to process data or information. So you can see on the screen, computing is the use of technology to process, store, and analyze data to perform tasks and solve problems, right? But why this processing is required? Yes, why this processing of data is required?
To get the raw information, to convert it into the useful information.
Yes, exactly. But what we will do with that information? If I need to process that information, what should I get?
The
So
results.
we can get the trends. We can get the trends.
So yes, so when we process information, we will move towards knowledge, and when we process that knowledge, we would come up with something that is related to uh, business directly. I'll relate this later on. So right now we are at the verge where we have just started using computers just to store information, and we will process it out, and then we will just analyze some data so that that data can be used in business. So I'll take another use case of that, but let's come back to cloud computing first. So now, what is cloud over here? Anyone can answer? What is cloud? Okay, no worries. So cloud is nothing but internet. So anyone who can give me the definition of cloud computing now, if you are aware about it? Yes. So basic,
Participants,
no worries, ma'am.
participants means anyone.
Let me talk. I think they do not want to interact. So let
Hello.
me process it in that way only. So
Good evening.
basic, yes, yes.
Good evening, sir.
Good evening.
And this sir, cloud computing is in which to store the users' information in the form of, and we can access our data from that database, like in the form of clouds, from anywhere and from by any time from the internet. That is
Okay.
called cloud computing.
Okay. So whatever I have said till now, let me set it in more processed way. Like, if you want to use computing services over the internet, that is what cloud computing is. This is the simplest definition till now. Like, you were using computers on your like computing services on your local machines. Now you have started using it over the internet, and once you have started using these services over the internet, it has become cloud computing, right?
Yes, sir.
Okay, so cloud computing is the delivery of computing services like servers, storage, software over the internet, enabling on demand access, scalability, and cost efficiency. So coming to these three keywords: on demand access. What is on demand access?
Sir, on the real time
Yes,
means.
so whenever I need it, then I'll use it, right?
Yes, sir. Yes, sir.
What is scalability?
So scalability, like many users can access the many can access the clouds, and in the form of means many users can expand and access the data from anywhere. That is
Okay,
scalability.
so scalability. Let me give you more brief, concept about it. Uh, let's take an example where you have a laptop whose capacity is like i3. Uh, hard disk is about 120 GB, and there are the basic functionalities. I would say. Now, what if you require a laptop for 1 or 2 days where you need more processing power? Let it be you need more RAM and more processing power. Let it be you need some i5 processor, and earlier your RAM was 4 GB and you need 8 GB. So is there any way out you can increase the processing power of your local machine, means your laptop? Can you change it from i3 to i5? Yes or no? Who says yes? Raise your hands. Can we do that? So can I say that like everybody is aligned on this? Like we cannot change the configuration in terms of computing when we are talking about processing power, or we are saying processor. We cannot change that because why we cannot do that? Because uh, there is a different architecture for i3. There is a different architecture when we are talking about i5. There is a different architecture whenever we are talking about other processors which are into the picture, right? Now we can increase the memory of that particular machine if there would be some extra ports over there, or what we can do, we can replace the existing memory chips with the more capable disk which are being required. So we can change the hard drive from 250 GB to 500 GB. We can change the RAM or RAM chips. So what we will do, taking it to 4 GB to 8 GB. But for that architecture which is used at i3, it should allow me to do that. So अगर मैं बोलूं like I need let it be 16 GB RAM in i3 systems whenever the motherboard architecture is somewhat the basic one. We cannot do that, right? But if we are saying like up to a limited capacity, let it be to 8 GB, it is allowing you to do that, then you will be able to do that. Otherwise, if you will use like 16 GB chip, it would be no use whenever your architecture is not supporting it. Coming to cost efficiency, so cost efficiency is something like whenever we are talking about cloud computing, we are taking everything over rent, right? And you are just paying for the services which you are using. So whenever we are talking about on-demand access, then what we will be doing, we would be like making a demand, and that demand is basically fulfilled by some of the cloud computing service providers, and for that they will charge you. So they will not charge you for the entire architecture or entire setup. They will just charge you for the services which you will opt, right? Coming to next point, where cloud computing offers deployment models such as public private hybrid clouds and service models like IaaS, PaaS and SaaS. So we will talk about these um, types of clouds and these service models in the subsequent slides. Till then you will have to wait. And other point is like widely used in industries. It enhances real-time monitoring, collaboration and data analytics. So coming to that point where I was saying what I will do with data. So let me take an example. If today you will search something over your internet, like let it be a pair of shoes, right? Um, on the very next morning, you will get advertisement of number of shoes which would be fitting into your budget and all. So you will get personalized advertisement. Now I'm taking a simple scenario where there are numerous number of users on the internet. They are using internet services, and that data is being generated by numerous number of users in every second. Now we need to process that data. So can you process that data by using your own machine? Yes or no? Can you process that data? Is it possible to process like GBs and GBs of data by using your machine, local machine which you are having? Is it
No,
possible?
sir.
Yes. So for that, you need a machine which would be having higher capabilities, right? So in this particular scenario, the role of cloud computing comes in, right? Where we can lease the servers on day basis or monthly basis or weekly basis, however you want to use it, right? Or maybe even like I want to use it for next 1 hour, I'll use that, and I'll delete that, I'll process that information, I'll check out with the results, and I'll delete that particular instance and come back with the results of that data. So I would not be interested in like what how I'll arrange that infrastructure or something like that, right? So I would come up with all my results which are into my hands, and then uh, by using those results I'll take the business decisions. So those business decisions can vary or may differ based upon the requirement of your business, right? Or based upon the requirements. So whenever we are saying like we are inculcating or amalgamating cloud computing in manufacturing services, so how we can do that? So we can take an example where we are you know, in manufacturing, what we are doing, we are creating some of the products and we are digitalizing its information over some internet or somewhere where we want to use that. In that case, what we can do that, what we can do, we can take help of cloud computing over here, where all the infrastructure would be taken from cloud service providers, and we will not require our own machine to process that data. So, this is the beauty of cloud computing. Like we will do it on demand. We will make it based upon the requirement, like the scalability, what we need. So today I need, let it be i3. Tomorrow I might need i5. So that can be done based upon, you know, at runtime. What I can say, like I need, even I to, you know, I can do that online, better to say. So, but there are various challenges while we are inculcating the cloud computing into manufacturing. So one is scalability issues. So what I'll do, like let's talk about IoT. So we are doing some automation in manufacturing. So if we take example of let it be industry 3.0 and 4.0, where we have started doing automation into the manufacturing, right? Now, while I was doing manufacturing, there was a data, and there are certain algorithms which are working behind that, right? And to process that data over those models which are working behind, what I need a strong machine, right? And that strong machine would be provided by cloud service providers or CSPs. Now, what happens whenever I would be integrating cloud into inter-domain kind of thing? There might be certain scalability issues where adapting to fluctuating demand without overextending resources. Sometimes it is not possible, but in most of the cases, cloud can do that. So there might be some challenges while we are, you know, doing manufacturing, and those challenges can be overcome by cloud computing. Technological integration. So whenever we are talking about industry 4.0, we are talking about automation. Now we are adopting various technologies like IoT, AI, machine learning, robotics to enhance the efficiency and productivity, right? But how, if I want to integrate IoT or AI or robotics by using my local machines, it is not possible for me. Or sometimes I would not be having that much of bandwidth with my machine which can integrate it. So what I'll do, I'll go for a cloud solution where there are multiple or numerous number of services. I'll show you after uh, the end of this lecture, like how practically we can do that. So we will use various platforms. It can be AWS, it can be Azure, it can be GCP for these integrations. So by doing it over the local machine, it would be very easy doing it over the cloud. High operational efficiency. So balancing labor, energy, expenses, all those things we need to take care, right? Coming to the next part, which is supply chain disruptions. So everybody knows, like these days, if we are talking about Amazon, Flipkart, or there are so many other vendors who are using supply chains, right? uh, where they can managing your orders to be delivered at your doorsteps. So for that, like how you are managing delays, shortages, dependencies on global suppliers, all those things need to be digitalized before moving to you know to a solution where we are supplying something to the nave user. Now let me take an example over here. What like what I'll say, like I have a company which delivers, let it be toys, right? Now in my factory, I'm generating numerous number of toys. Let it be I need some Avenger toys, and demand for, let it be for Captain America, was for, let it be 500 toys. I have manufactured only 200. There is a gap in manufacturing and supply. So demand and supply gap is there, right? So to overcome that gap, cloud computing can help. It can digitalize all this information. It can basically help you and your customers to tell, like, where exactly your parcel is right now. So these days, if you go to Amazon, you can see, like, once you will purchase your product, it would be like where it is right now. It is giving you real time data. Like right now it is in at, let it be at the initial location, then it moved to the another, then moved to the another, and even it will tell you, like, in how many phases it would be delivered to your doorstep, right? And in how many days it can be delivered. So these days when we are saying, like, everything has to be delivered within 30 minutes or something, we have a concept. So to inculcate or to implement these concepts into real time, we need very powerful machines, which cannot be done by local machines, and that support will be provided by cloud. Data management. So as I already told you, numerous or large amount of data is being produced by users. Moreover, these days, if you have heard about this IoT and something, what is happening earlier when we have started, or we have stepped in into digitalization. What we started with, like, we were having a heavy amount of files in our offices. We have started digitalizing them into our computers. So earlier there was a simple file, you can say that pen and paper kind of arrangement, and that arrangement is then converted to digital one. And these days you need not to give written application or something. You need to fill up some of the forms online, and you can track your application like where it is right now. So we have started generating that kind of data. Then these mobile phone came into picture, where we have started taking pictures, videos, textual data, visual data, and now we are at a verge where we are having data farms or data warehouses. And out of those data warehouses, we need to process the information and need to provide meaningful information, where there are various tools which are called data analytics tools, and those data analytics tool would help you to get the insight of those data points, right? But again, to process that data, we need, or we require servers. So those servers are basically coming from some location, and that location is of cloud service provider. Then coming to the next part, where we will be talking like what are the benefits of using cloud computing in manufacturing. So as I already discussed it in the previous slides, like there were various challenges, and those challenges were basically uh, solved by cloud computing in such a way where we are not using our own machines, we are using the services over the internet. So what it has done for us, so whenever we are talking about, especially about manufacturing, improved agility and scalability. So at any point of time, if right now today my shop, the valuation of my shop is, let it be 10 lakhs. So I'm having products of 10 lakhs in my shop. Tomorrow I'm planning to expand it. So based upon that expansion, I can come up with various resources that can be taken from cloud service providers, and need not to spend much over the physical infrastructure which need to be deployed at the stores, right? So if you have ever gone to superstores, over there you can see like everything is computerized, digitalized. So from taking any product till you take it to your home, everything would be digitalized. They will take your information, and then they will give you various discounts and all, right? So in superstores, they would be doing it over their local machines, but those machines, very little processing power is required. So those are basically data entering machines. Those machines are not the machines where they are processing that information, because the processing of that information is required at another level, like कितनी items थी जो बिकी, कितना profit था, all those information is required at managerial level, not at salesman's or the person who is selling products over there in the store, right? So this agility, this scalability was possible with the help of cloud computing and its inculcation into manufacturing practices. Enhanced accessibility and collaboration. So if we are talking about like as rightly said, like we are doing it over the internet, so whatever is happening in a store that is situated at Chandigarh, I can take all the insights from, let it be from Solon, or maybe from America, or any other location, right? I need not to be present at that particular location. So even I can track, like in last hour, how many products are being sold out, right? So this can be the things which can cloud computing has given you, that accessibility and collaboration kind of environment, where cloud-based data storage and analytics platform enable manufacturers to access and share the data easily and on frequent basis. Coming to next point, which is fostering innovation and efficiency. So cloud computing enables manufacturers to adopt new technologies and processes more quickly. So let's take an example. If I'm having a physical infrastructure installed in my premises, I need to make some changes into that, which is a little difficult for a for a manufacturer, or maybe for an owner of that particular business, whenever we have installed it physically. But if we are talking about taking it over the lease, then it is very easy for them to foster that innovation into their businesses. Coming to the last point, which is reducing hardware and IT costs. So this is what I was talking about since I have started this lecture. Like we internet has replaced the physical infrastructure with these required set of services which are being used in cloud computing. Coming to the next segment, where we will talk about core concepts of cloud computing, where we will talk about types of cloud deployment models, where there are various models like public, private, hybrid, and there is another model which is there into picture these days is community cloud. Other than that, there are various service models which are being provided at cloud environment by various CSPs, that is infrastructure as a service, platform as a service, and software as a service. And then we will talk about key features like scalability, cost effectiveness, and flexibility of these solutions into the existing businesses and manufacturing practices. So let's talk about the deployment models. So I have already told you, like there is a public cloud, private cloud, hybrid cloud, and community cloud. So I'm sorry, there is something else written over the slide, but it has to be hybrid cloud. So public cloud, let me take an example. Public cloud is something which is available in public interest. So if I'm the normal public, I can go and purchase it. There is no hard and fast rule. I'll go various CSPs, जो जितने भी major CSPs हैं, like AWS, if you have heard, Microsoft Azure, then Google Cloud Platform. So GCP belongs to Google, Azure belongs to Microsoft, and AWS belongs to Amazon. So these are the major clients in the system who are providing these cloud services to the users. Again, public cloud is something I told you, like it is in the public interest. So anybody can go to these platforms, create their own account, and start using the services. Whenever we are talking about private cloud, there is something which we would say like exclusive to single organization, providing greater control, security, and customization. So when we were talking about public cloud, so there is a proverb like if something is available over the internet, it is never secure, right? So if it is freely available, it is never secure. So whenever we are talking about public clouds, they are secure up to some extent, but if it is compared to private cloud, they are not secure as private cloud are secured. So in private clouds, exclusive to single organization, providing greater control, security, customization, and it can be hosted on premises or by third party vendors. So let me tell you a story. When we used to be over there in some of the universities, I'll not take the name. So what happened? We were having some hardware which was basically getting old, and we were replacing that hardware with the newer version of machines, right? So earlier we were having i3 systems or even atom processors were there with us, and then at the very first year of that particular university, this infrastructure was enough. But then what happened in the very few next few years, we need to replace that infrastructure. Why? Because the software installation requirement has changed from basic softwares to specialized software, and those specialized softwares were basically working on machines which would be having specific processing capabilities, right? So we have replaced i3 machines or atom processor machines with i7 or i5 machines. Now half of the infrastructure that was built at first year was useless for us, because I was having only specific location labs where I can install those machines, and previous machine has to be like either it has to be stored in storerooms, or I need to sell them out, but I would not get more money out of that. So what we did as managing that IT infrastructure, we have taken a single room, uh, no infrastructure like table, chair, and all. We have just installed the electricity points, with the help of which we can basically switch on those machines. We even do not require more monitors. So monitors which we have purchased earlier, that were already there into those labs, we have just replaced the mm, CPUs of that lab. Now the CPUs which we were having were like we have tried to sell them out, but we were not able to get higher price. Like we have got them in, let it be 25,000, and now we were getting only 10,000 uh, whenever we are selling them out. Now what we did, uh, we in we took a room, and without any specific infrastructure, furniture infrastructure, what to be very precise, we have just installed the electricity points. We have switched on the machines. We had made a network, and on that network we have made a cluster, and that cluster, in that cluster we have combined the processing power of those machines. Now that processing power which was collected as a cluster was more than a server. Now what we did, uh, we have just kept the make the arrangement like these systems should kept on all the time, and leased out that processing power to a cloud service provider, which that service provider has again like sold that out based upon the requirement of the users of its clients, right? A client base. So this was one of the experiment that we did to make a private cloud and then sell it out to some CSP, and got more money as compared to selling those machines and in racks, or to the vendors who are just taking them as outdated machines. So this was one of the concept where we have used a private cloud, and you know give it on rent, and on monthly basis we were getting lakhs and lakhs of money. Other than that, whenever we are talking about hybrid cloud, so hybrid cloud came into existence when we talk about like I need the security of private cloud and accessibility of public cloud. So we have merged the features of these two cloud deployment models and made a one you know one model, which is then called as hybrid model. So it combines public and private clouds, and allowing data and applications to move between them for enhanced flexibility and optimize resource uses. And now let me take an example. Public cloud is like public transportation. It is cheap, but it is not that much secure. It is not that much uh, that much private, or it will not give you more privacy as compared to your car. So if you are taking it as a car is your private cloud, whereas there is a bus you are using on daily basis, that is a public cloud. Coming to hybrid cloud, it is something, if you have ever used blah blah, or maybe you can compare it to the shared taxi. right? Or rented cars. So you need not to pay for the whole car. What you are paying for, like from one place to another, so there would be certain amount that has to be given to the owner of that particular taxi or car, and then you can use it. Now coming to community cloud. So community cloud is something where two or three organizations are from same stream and having same interest. Let me take an example. Like there are two organizations, or maybe there are two healthcare organizations. So those two healthcare organizations would be having same interest. So they can combinedly take a cloud service with some another organization that would be having similar interests. So if I can say, like, some healthcare organization cannot make a community cloud with, let it be, educational kind of organization. So for educational kind of organization, we need some same kind of, like edtech can make that uh, community cloud with the organizations, educational organization, because of similar interest. So this is the basic, you know, difference between these deployment models. So you can say, basically we are having four type of deployment, where one is hybrid, uh, which is the combination of both public plus private, and then there is another set of deployment model, which we call community service, which is for specific organizations. So either it can be healthcare organization, it can be research organization, it can be educational organization, or it can be any other organization having similar interests. So public cloud, we have already taken that example. Like public cloud is nothing but it is like the public transportation kind of model, uh, where you can take the services from a CSP, and everybody is free to everybody. Basically, the audience is not limited to that particular cloud. So you can see it in the picture where there is a user from company A, then there is a user from company B, then there is a user from company C, and there is a user from company D. So there are different set of people which would be having different interests. They are using services based upon their requirements from the public cloud, right? So this is what we call public cloud. So public cloud is a cloud computing model where services like storage, application, virtual machines are hosted by third-party providers and delivered over the internet. So whenever we are talking about cloud computing, it has to be over the internet. That's it. It is shared among multiple organizations, so multi-tenancy is there, and making it cost effective and scalable. So scalability is the main feature of of basically cloud computing. And whenever we are talking about cost effectiveness, that would depend upon what kind of cloud you are using. What are the key features? So key features, you can say that it is cost effective, it is scalable, it is accessible, it is maintenance free. So whenever we are talking about public cloud, the cloud service provider would manage infrastructures, update, and the security. What you need to take care about is your data only. So in this particular picture, you can see, which has just came in on the deck, where what is happening. Public cloud, so hosting websites and applications is one of the use case. Then data storage and backups, that can be done over the public clouds. Coming to the third use case is development and testing environments. So basically whenever we are using public cloud for this kind of segment, it would be cost effective plus more flexible. Private cloud, as I told you, it it would be the securest one, most secure one, but it is not cost effective. So basically, it is just like you are buying a car. So buying a car is not cost effective as compared to using transportation services which are into public domain. So if you are going by your car and you are using a public transport, that that pricing cannot be compared at all. So you will have to take care of all the segments where maintenance of that thing. You have to pay for the fuel. You will have to drive it in your own way and all. So, or if you want like someone else should drive it, in that case you will have to hire a driver also. So it is the most costly kind of environment in a private domain of cloud. So a private cloud is a cloud computing model which is dedicated exclusively to a single organization, which is offering greater control, security, and customization. So whatever I need, I can do that. Like if I want to drive that car by myself, I'll do that. If I want to hire a driver, give it to it, and then I want to go from one place to another, that is also possible. If I'll say I have a friend who know how to drive, I can give it to my friend, he can drive it for me. So all those customizations are available in case of private cloud. But now taking you back to public cloud, if you have a friend who know how to drive, but again you cannot drive a bus, right? So which is into the public interest. So that has to be like for public kind of thing. There would be a set of department who would be giving drivers. Those drivers would be taking that vehicle out and getting the passengers from various places. But it would be a normal model. But the customization would not be available in case of public cloud, right? Because once I would be having that kind of arrangement, if I'll say it is ordinary bus, so you cannot change its seats. But whenever it is a Volvo, then again you cannot its seats. So that arrangement is being prepared previously. But whenever we are talking about private cloud, that customization is possible because you would be having more control and more security over the resources which are available into that particular interest. So let me take an example, like a company hosting its own private cloud infrastructure on premises. It's one of the use cases. Third party manages the private clouds like VMware or IBM private cloud. These are the two examples. Just a minute. So you can see the diagram. So there is a customer network, then secure VPN would be provided, and under the customer's premises, all the services would be accessed whenever we are talking about private cloud. You can see it in the picture. So what are the key features? Exclusive access, customization, control, enhanced security are all are the features of private cloud. And what are the um, use cases whenever we are talking about data governance? This is one of the use cases whenever we are handling sensitive data, where government agencies, research data, financial institutions, they all are using private clouds because their needs or their requirements are something different as compared to the users which are using public clouds. Coming to hybrid cloud, so hybrid cloud is the mixture of both public and private, where we have taken the features of public cloud and private cloud on one single platform and provided it to the various users or clients based upon their pocket size. So hybrid cloud is a type of cloud computing that combines public and private clouds, enabling data and applications to move between them. This approach offered flexibility, scalability, and enhanced control by leveraging the best features of both the environments, right? A retail company uses a private cloud to store sensitive customer information for security and compliance purposes. Simultaneously, it leverages a public cloud to manage fluctuating website traffic during the peak shopping season, such as Black Friday or any kind of day, like or seasonal, or you can say that on a very particular occasion, right? So let me take an example. If we have a retail store, so there are two kind of data, like that retail store wants to tell its users, like they are having these type of products in public interest. This is the pricing range, these are the discounts, these are uh, uh, various coupons which can be applied. So that information has to be public. So for that they are using a public cloud. But whenever they are talking about like how many sales they have done in a day, that has to be something which relate to private domain. So to hide or to protect that particular information, they are using private cloud. But whenever they are they are talking about any data which has to be in public interest, that has to be on public cloud. So they have taken the advantage of both the models, and these features has helped them to manage both the environment. So what are the key features? As you can see over the screen, flexibility, cost optimization, scalability, and interoperability are the main features of hybrid cloud. Let me show you another diagram where these hybrid clouds can be used. So whenever we are talking about disaster recovery, so we can do it in case of disaster recoveries where we have to take data backups, we have some recovery plans, and simultaneously we have to scale the resources when there would be a particular occasion. So I'll say, like, if you all are from the same community, let it be the education community, your website might use the resources which are limited on normal days. But whenever the result is out on that particular day or for that particular week, you need more processing capabilities. So over there, you need some scalability of the resources. So in that case, what you can do, you can go for your public public cloud deployment. So where you can scale up your data, but now your ERP has to be in the private cloud. So so how those results are being created out of that data, that data is not private. What is public data? Where you can show the grades of the students, how many students have passed, how many students have cleared courses, or they have promoted to next class. These can come into the public interest, but how, like, which student has got how many marks in which course, that is not actually required these days. So that has to be done by using private cloud. So now we can say that hybrid cloud is the combination of the both. Community cloud. So whenever we are talking about community cloud, I already told you, like, if there are two organizations or three organizations of similar interest, they can combinedly use the community cloud. So it is just like three companies are over there at so let me take an example, like what I did. I have an IT, my friend is having an IT company, and his, again, there is a common friend, he's also having IT company. So we would be having similar number of employees. So what we did, like our timings were different, but our interests were same. So what we did, we leased out an apartment for office space, or what we can say, we have leased out an office space which can be shared among these three companies. Now let it be, I'll say from early 6 o'clock in the morning till let it be 2 o'clock in the noon. It is the resources are being shared by company A, and then after 2 o'clock company B can take over those resources, and after a certain time period, let it be at night shift, that those resources can be used by the third company. But over here, there is one common factor, that is similar interest. I said, like, if all are from IT background. So for IT kind of companies, there would be different set of, office environment, but or infrastructural, requirements. But if we are talking about, let it be any another educational institution, it can be different one. So now you can say that, like, if there are three organizations and they are agreeing to use or to share the resources of similar interest, then it can come under community cloud. So we can say that healthcare organization sharing a cloud for managing patients records securely. Educational institution collaborating on research data storage. So I'll say, like, Amritsar Khalsa College, and let it be Lovely Professional University. They have taken a community cloud, and then they are sharing, um, space to store their research collaborated data over the internet. So that would come under community cloud. Then key features, so shared infrastructure is there, again cost effective, efficiencies are there in this particular case, and custom security and compliances. So I'll say, like, organization A might have certain another set of requirement for security, but organization B might have uh, certain another requirements. So that can be customized based upon the requirements. So these are the use cases, like healthcare. We can use it in financial services. We can use in education and research. Then there are various education agencies which or government agencies who are doing this over the community cloud. Now, cloud service models. Cloud service models are like infrastructure as a service, platform as a service, software as a service. So I'll not go much into details. I'll give you simple use cases, like whenever we are hosting websites. Okay, so in that case, we just require the infrastructure as a service. I need some servers, I need some virtualization space, I need some networking and storage kind of thing, or I need some data center. In that case, I'll go for infrastructure as a service kind of arrangement. So where I would be dealing only with infrastructure. So what I did, I have taken infrastructure on rent. This is what we call IaaS. So हमने servers जो हैं वो rent पे ले लिए. In that case, it would come under infrastructure as a service. So use case, hosting websites, running virtual machines, and data storage. Platform as a service. So platform as a service, we can take example like Google App Engine. We can say Microsoft Secure Azure application. We can say that AWS Elastic Beanstalk, or the use cases can be developing and deploying web or mobile applications. And whenever we are talking about software as a service, we would be having different set of users, where we would be using CRM systems, where we would be using email services and all. Right? Are you listening to me, guys? Are you awake? Yes. Yes.
Yes,
sir.
Okay. So is there any doubt till now? Yes. Okay. So I'll assume that there is no doubt till now, and I can move forward. So software as a service, where we would be using email services, CRM, and project management tools. So I'll take another examples of it later on. So understand this, like what exactly IAS, PAS, and SAS is. I have taken pizza analogy. So let me take the example where you have to cook pizza at your home. What you would require. So whenever you are doing it at home, it is something what we call like on-premises infrastructure, right? So you will have to manage each and everything. So anybody is there who can give me, like, if we want to cook pizza at home, what we would be requiring? Anyone?
So we require pizza base for that.
Yes. What else? Yes.
Oven, microwave,
Yes. Yes, microwave oven, or and
toppings,
sauces, toppings.
sauces,
Okay,
vegetables.
so let me show you a diagram. This is the traditional way. First one is made at home. So what we would be requiring? We would be requiring a dining table first of all, right? We would be requiring soda, electric gas, oven, fire, pizza dough, tomato sauces, toppings, cheese, right? All these things are required at home. So I like, if I want to cook it at home, I require each and everything. So it would be like, I need the ingredients of pizza, plus I need you know an infrastructure at home, right? What if I'll say I'll use the service take and bake. So bake and take opportunity. I would be requiring, a dining table, soda, electric gas, oven, and fire. Is it? Yes.
Yeah.
And pizza dough, tomato sauces, toppings, and cheese would be provided by the service provider. So whenever coming to platform as a service, then I would be requiring only a dining table and soda. Rest everything would be managed by the vendor. So basically here you can say that you have taken the delivery. Like you are using Zomato, you have ordered it from Zomato, but it is delivered at your home. So you are using, like, you are having it with cold drink, so you have to arrange cold drink and use your own dining table, whereas the other infrastructures will be, and the ingredients would be provided by the service provider. What if I'll say I'll dine out, I'll go to let it be Pizza Hut, or maybe Domino's, and I'll just pay, eat, and come back. So this comes under software as a service. So let me redefine it when I would be doing it for cloud. So IT analogy, how it would be. So whenever it would be on premises, I need to do networking. I need to take take care of storage. I need to take care of servers. I need to take care of virtualization. I need to take care of the operating system. I need to take care of the middlewares. I need to take care of runtime, like machine should not shut down. Then I should take care of the data, applications, each and everything. But whenever I'm coming to infrastructure as a service, where like what you will have to manage: the operating system, middleware, runtime uh, of that particular machine, data, and applications. Whereas the cloud service provider will manage all the infrastructural part, where networking, storage, server, and virtualizations would be provided by that party. Coming to platform as a service, where you need to take care only about your data and the applications which are required to run that data at runtime. Otherwise, all other services would be provided by the CSP. So whenever we are talking about networking, storage, servers, virtualization, operating system, middleware, runtime, so that will be managed by the CSP. Now coming to software as a service, where you need not to take care of anything. You will just give your data to the service provider, and each and everything would be done by that service provider. Then it comes under software as a service. Now, just one question: which would be the most costly one in out of these services? Yes, according to you, anyone? Hello, are
Sir,
you
I
there?
think
Yes.
on premises.
Yes, for on premises, I need to take care of everything. And if I compare these three services, IaaS, PaaS, and SaaS, in that case, which would be the most pricey?
IAS, I think, sir, IAS.
Okay. Any other opinion, please? Yes. So according to me, it has to be SaaS. Why? Because whenever you are going for this kind of arrangement, you will have to take services of IaaS and PaaS both. So out of these three, the third one would be having more price. Am I clear, or should I take some example for this?
Yes, sir. Yes, sir.
Okay. So next segment, we would be talking about the applications of cloud computing in manufacturing services. So if we talking about like smart manufacturing and industry 4.0, we are talking about cloud-based supply chain management. We would be talking about collaborative design and virtual prototyping. So whenever we are talking about manufacturing, there is a segment which would be dealing with virtual prototyping. So these days, this is the most common one. So that is why I have chosen it. Otherwise, there are numerous number of applications of cloud computing in manufacturing. But I have specifically taken these three, where we would be talking about smart manufacturing and industry 4.0, then some supply chain management, and then collaborative designs and virtual prototyping. So coming to the main outline of this, where we are talking about smart manufacturing and industry 4.0. So when industry 4.0, as you all are aware, deals with automation, and that automations is done with the help of various sensors, with the help of various actuators, with the help of various services which are running behind. It can be various algorithms. These algorithms can be machine learning or AI algorithms, which are working behind to make those decisions out of the data which is being captured by sensors, actuators, and all. Right. Then predictive maintenance and operational efficiency. So let me show you a diagram where what happens when we would start automation by using IoT integration into the normal environment of manufacturing, where let's take an example where a car manufacturing company has integrated IoT, or make it automated, fully automated, right? So there would be various sensors. Now those sensors would be sensing some data based upon the environment which would be there in that particular segment, and then that data is sent to a machines which would process it. But now we are talking about an environment where your machines are generating data. So earlier what was happening, human beings were generating this data. Now when human beings were generating this data, the volume was not that high. At that time, I can like my normal machines would have processed it easily. But when machines has started generating this data, I need specific processing power, and that specific processing power is not available at local machines. So I need cloud computing. So what has happened when I have combined IoT with cloud computing? We have come up with two major things. One was operational efficiency that was achieved through the IoT integration, and other thing that I have got was real-time monitoring. That real-time monitoring was possible with the help of cloud computing. So whenever we are talking about real-time monitoring, that predictive maintenance would come into picture. But whenever we are talking about operational efficiency, that comes up with the help of automation and data-driven decision making. Now there was a data that was produced by those machines, and based upon that data, machine has to take certain decisions. So those decisions would help me to get that automation process better. So again, coming to the inculcation of these two, we have come up with certain, operational efficiencies plus predictive maintenance, which have reduced the downtime of my business plus optimize the maintenance schedules. So I would be knowing like when there is a requirement of maintenance in my, production house, right? That thing has, or that information has been taken from the data which is being captured by various sensors. Coming to cloud-based supply chain management, so end-to-end visibility. As I already told you, like whenever we are talking about these platforms where Amazon, Flipkart, and there are Mintra, there are so many platforms which are using these supply chains. And these supply chains are then inculcated with cloud-based models. And with the help of this, what we got, end-to-end visibility. Cloud platform provides real-time tracking and monitoring of entire supply chain, enabling manufacturers to gain transparency and take informed decisions. So when I would be having that data in my hand, I'll say like in that particular store, there are, let it be 500 items and I need to deliver, let it be 1000 items. So there is a deficiency of 500 items. So anyhow, I will have to fulfill that deficiency in that particular store. So this was basically possible with the help of cloud-based environment which are being inculcated into supply chain management systems. Enhanced collaborations where cloud-based tools allows seamless communication and data sharing among suppliers, manufacturers, distributors, and the end users, what we call that customers, for improving coordination and reducing lead times, right? Coming to demand forecasting, as already I told you, like if there is a gap between demand and supply, that can be easily tracked by using these systems. So you can see it in the picture where everything is happening in front of us, but there is a cloud infrastructure which is working behind the scene, right? So you can see like there are various technologies which are being used over here. So request, then that request is coming to edge layer. From edge layer it is going to storage block where it is being stored at suppliers end. Then there are some other technologies, what we call that blockchain, which is helping the entire ecosystem to make error-free decisions plus a secure kind of communication between all the stakeholders in this particular ecosystem. And that ecosystem is then equally supported by the cloud infrastructure at backend. So this is how it is happening. So where I was talking about sensors and IoT devices, where automatically that supply chain is working. So I'm having sensors, I'm having IoT devices, and based upon those IoT devices, some requests are being generated, going to all the stakeholders and coming back as a fetched information, processed information to again to the edge layer, and that response is being provided to end user. Then collaborative design and virtual prototyping. This is one of the major concepts these days whenever we are talking about manufacturing. So global collaboration, virtual prototyping, scalability, and accessibility are the three major components in this particular segment. So we can say like global collaboration. So what I can do, if I have a design, I can share it with a company which is situated at US or maybe in another set of regions, right? So a cloud platform will enable real-time collaborations among designers, engineers, and stakeholders across the different locations, enhancing teamwork and innovation in product design. So whatever the design I'm generating over here, I can share it real time with my boss who is sitting over there at US, or that like my boss can share it with all the other stakeholders that can be the client of the company on real time basis. Like these are the progresses which are being made throughout the entire process. So this is the beauty of these collaborative designs and virtual prototyping by using cloud computing in manufacturing services. So virtual prototyping, you can say that like CAD CAM might have used who are from uh, other engineering backgrounds, where we are talking about civil and mechanical. So you can create various designs, but now that virtual prototyping is one thing which is in the market these days. So this virtual prototyping would help the all the stakeholders to show what would be the end product, right? So if you would have ever gone to this lens cart showroom, so they are giving you real time or if you have ever used lens cart's application over your mobile phone, so you will select your face, you will select the kind of specs you want, the specs the goggle you want to purchase, you will select it, you will it would give you the real time environment where like how it would look like over my face and all. So this is again one kind of the applications which was possible with the help of cloud computing, because to process this particular prototyping, it requires a lot of processing power that is not available with my mobile phone. So at mobile phone, you are just using that application. What the data which it is processing at the ultimate end of cloud computing. Coming to scalability and accessibility, so at any point of time we can do that by using cloud computing whenever we are talking about internet kind of environment, because whatever I'm doing right now, it would be accessible to each and everyone in the whole ecosystem. So next segment is enhancing scalability through or by using cloud computing. We would be talking about elastic scaling of the resources, handling variable demands in manufacturing. Then we will talk about cost implications and scalable solutions. So elastic scaling and of resourcing, key concept is like at any point of time I can increase the size of my resources, I can scale them up. So I can scale them up, I can scale them down. So based upon the requirement, what I can do, like I can increase the power of my machine at any point of time. So these are the virtual machines or instances, or there are so many other names which are being given to it in the regime of cloud computing. So scalability allows manufacturing to adapt the changing operational demands efficiently, and then this elastic scaling of resources would help me to scale up the computing power, storage, and applications up or down based upon the demand of my business. Avoid over provisioning or underutilization of the resources. Automatic scaling of during peak production seasons or new product launches. So whenever there would be a new product launch, let it be at Apple, do you think it needs the same processing power at is it needs on normal days? No. on that particular day, there might be the requirement of more processing power, more storage, more, more manpower and all. So that can be managed by using cloud computing services. So you can see it in these diagrams which are being shown over here in this particular slide. So we can scale up and scale down the resources at any point of time. Handling variable demands in manufacturing. So key concept was adapting to fluctuating workloads with cloud computing. So dynamic demands management, scale operation instantly to meet unexpected demands, surge or drops, manage uninterrupted production and supply chain efficiency. And its use cases can be the set of manufacturing agencies which are handling seasonal demand spikes with cloud-based resource allocation. You can see it in the pictures. So cost implications of cloud solutions. Key concept is scalable cloud model ensure cost efficiency by enabling pay as you go flexibility. So whatever you need, you will pay for that. It is the main feature of this cloud computing environment where you will use pay as you go model. So it will reduce upfront investments and maintenance expenses. Pay as you go pricing, you will pay only for the resources which are being used while you are working on certain set of processes, reducing capital expenditure and IT infrastructure, align costs with actual uses, and we can draw various trends by using those data. Like whenever I need more power resources, whenever I need more computing power and all. So this can be aligned with the cost, or it would be pocket friendly for each and everyone whenever it would be over the cloud. So case study can be a manufacturing company leveraged scalable cloud models to reduce IT costs, enhance operational efficiency, and dynamically scale operations globally. So next set is like how we can foster collaboration with cloud platforms. So these are the various tools which are being used in manufacturing practices for various operations. One is Siemens Team Center. So it is a cloud-based product lifecycle management tool enabling global teams to collaborate on product design, development, and engineering. So, like in spite of the location of the employees, it would give you that leverage where one employee can use one set of resources at let it be in India and other can use it at US. So if you would be having that kind of environment in this particular software. Autodesk, everybody would have used uh, PTC Windchill. So this is one of the software which is uh, used in manufacturing practices. Azure IoT Central. So this is something which deals with automation of your stores or the production house, where IoT Central is the device that would manage all your sensors, collect like how it has to be represented, how it will gather information, and how it will process that information, and at the end how it will take the smart decision for that. Google Space, Workspace, you all have used it. Like if you are using Google Drive, you are using Google Docs, you are using Google Meet. So it enables seamless collaborations on design, documents, production, schedule, and team communication in real-time scenarios. So you can see like there are various tools which are being used in production, and these tools are basically cloud-based tools where whatever you will do today uh, would be reflected on real time to the other set of users which would be at different locations. So real-time communication, I already told you. So what would be the impact? Real-time communication empowers global teams to stay connected, enhance collaboration, and deliver project efficiently in today's fast-paced manufacturing environments. So seamless collaboration, instant communication, enhanced productivity, and reducing IT hardware cost are the main features of this kind of environment. Secure sharing of design, files, and data. So in this particular set of environment, the impact would be secure sharing of design, files, foster collaboration while safeguarding critical assets in competitive manufacturing landscape. So what are the challenges? So data security is one of the challenges, but again it depends upon what kind of model you are using, right? So what type of encryption you are using, multi-factor authentication you are using, what are the regulatory compliances, whenever we are talking about various models which you have chosen for your business, or the manufacturing practices which you are using at your production houses. Integration at legacy system, so complexity, downtime, and investment. These three things need to be taken care whenever we are using cloud computing in manufacturing domains. Training workforce. So whenever we are talking about training workforce, it is not required up to that extent, but still, whenever we are talking about cloud, there are various set of services which required more attention while using it over the local machine. So you can say that if you want to use cloud, I'll give you a simple example at the end of this presentation, like how we can create a virtual machine over the Azure platform, right? So you would be able to know like how easy it is, but still it requires some kind of expertise how to create it over the various cloud platforms. So what are the best practices? So best practices, like you will have to select the right cloud service provider, right? Choosing right CSP is the main set of rules which is applied over here. So you will have to evaluate providers based upon their services, like how scalable their solutions are, how reliable they are, and compliance with industry standards or not. So basically there would be various regulations which are being provided by your industry standards. So whether that service provider is giving you those set of flexibility to match with those regulations and compliances. Consider offerings like IoT integrations, data analytics, and support for smart manufacturing or not. So this has to be taken care before like moving towards cloud-based manufacturing. Implementing robust cybersecurity measures. So I already told you there is a need to implement security solutions whenever we are talking about cloud environments, because if something which is available over the internet, it is not that much secure, but still cloud platforms are providing some set of security uh, measures for these cloud platforms, but still you will have to know like what end-to-end encryption types are used by those CSPs, either they are using multi-factor authentication or not, whether regular security audits are being done by the company or not, whether it can protect your sensitive data or not. So all these things you need to take care. Establish access policies of the data, where like who can use your data at what level. This has to be provided at cloud. So role based access is one of the features, but most of the cloud service providers are not providing it to the end users, and again it depends upon what sort of services you are using from them. So these are the best practices that can be used. So any queries till now? If there is no queries, then I'll directly move to the practical implementation of the virtual machines over Azure. Anyone? Any questions till now? So anyone who is aware about Azure, what is Azure? So it looks like something like this. My screen is visible, right? Yes. Yes. Is it visible? Okay. So let me create a virtual machine for you. I'll go directly to virtual machine. I'll click on create. So this is a kind of sandbox I'm using right now. So your organization can also provide it. So these are basically solutions which are provided by various companies just to ensure like user can use these services and then delete the resources which they create. So what I'll say, I'll use this particular resource group. So resource group is nothing but I have created a group which would be streamline the resources which I'll use while using the services. So I'll say I'll create a machine, virtual machines, name FDP1. Reason by default it has selected because I have this subscription. So these are the zone availability. Like availability zone is like where are these services are being deployed. So this is what the zone is. So see, I need not to do anything. What I'll do, I'll create username for my virtual machine. I'll say password would be this, and I'll say review and create. So based upon the bandwidth of your internet, it will give you, there is you will have to provide some information, and then yes, you need to click on I hereby confirm. I'll say create. Let there is some problem at this. Let me. Okay, so in these subscriptions you cannot use premium SSDs. You have to go for standard. Then you will have to review and create. RDP ports are enabled or not. So RDP is nothing but remote desktop procedures with the help of which you can access that machine from your local machine which you are using right now. So you can see, yes, hello.
Sorry to say, time is over. Schedule was till 7:30. Next speaker is waiting. Could you
Okay,
please
just give
invite
me
them?
5 minutes, ma'am. I'll wrap this up.
Sure. Right, sir.
Okay. So this is the deployment which is in process. Now it will take some time, and then your machine would be, you know, uh, deployed. And once it is deployed, you need to connect it. And by like how you can connect it, like there would be some RDP kind of file that you will have to download, and you will have to click on that RDP file. And once you will click on that RDP file, you can directly use it. So this is the simple procedure for creating these machines over the like Azure or AWS. So sometimes these processes can be different, but we can say that like these are the super easy procedures which are being used over the cloud, and within minutes you can create machines and use them according to your business and requirement. So thank you so much for your time. Any queries? Okay, in that case, I'll wrap this up. Thank you so much for your time. Thank you so much for providing me this opportunity. Thank you so much. Bye-bye.
Thank you so much, sir. It was a wonderful session. Thank you.
Thank you. Bye.
Thank you.
Thank you, sir.
Participants are requested to wait. Our next speaker of the day, next resource person, Dr. Narendra ji. He will be joining us very soon. Dr. Khushleen? Dr. Narendra has joined, I think. He has joined. Dr. Atul, can you please confirm? Dr. Atul, can you please confirm?
Yeah, actually I have joined.
Ma'am, sir has joined. Please,
okay,
please carry on. Sir has joined.
Please, Dr.
Am I audible,
Khushleen?
Dr. Atul? Am I
Yes.
audible?
Yes,
okay,
yes,
thank
sir.
you. Thank you. Thank you.
Our second speaker
Thank
of
you.
the session is Dr. Narendra Kumar, who is working as Assistant Professor, Grade 1 at B.R Ambedkar, NIT Jalandhar. His topic of the day is Additive Manufacturing Production and Prototyping. Over to you, sir.
Thank you, ma'am. Thank you so much. Just wait, I'm going to just open my presentation, right?
Sir.
So, ma'am, could you please confirm whether my screen is visible to you or not?
Yes, sir. Screen is visible.
Okay, thank you. Thank you so much. So, very good evening to all. And I hope you all are doing very well. So I once again welcome you all in my second lecture of this particular FDP. So today I am going to discuss about the additive manufacturing, or it is also known as 3D printing. Last time I also highlighted the features, why it is so important in the industry 4.0, right? how it can transform the existing production line and the prototyping approach. So here, this is the content of my slides, or even say the lecture. So as in my first lecture already, I have covered the content related to Industry 4.0, and I also discuss the core pillars of Industry 4.0, in which in which this additive manufacturing or 3D printing was one of the key pillar, right? And then I will be talking about the role of 3D printing in the Industry 4.0, and then I will highlight the definition of 3D printing, right? And what are the process chain, different applications of 3D printing, and what kind of challenges we are facing right now, right? Or what are the future trends where we are moving, right? So this is the overall key outline for my lecture. So let us start with the industrial revolution 4.0. So in my first lecture, I have already discussed about this slide. So here we have seen that the fourth industrial revolution basically is based on the cyber physical systems. So under Industry 4.0, we will have the this smart factories, right? We will have more focus on the customization. We will have the focus on the AI, ML. So a lot of technologies will be there under Industry 4.0. And I also highlighted the just wait actually. Yeah. I also highlighted the role of additive manufacturing in the Industry 4.0, right? It will help us to reduce lead times, and it will promote the on-demand production of the products. It will also promote the decentralized production by just establishing the localized 3D printing hubs nearby to the cities, right? So, and next one is the 3D printing has capability to create parts without the use of any mold or any tool. So customization can be achieved with ease, and then it will simplify the supply chains, right? By just reducing the intermediaries stages, and on-demand 3D printing of spare parts, it will promote and then reduce waste and improve sustainability. That is also one of the key feature of Industry 4.0. And it will also facilitate the faster product development and prototyping, right? And also we can design the more complex geometries, right? We can fabricate them with ease as compared to the other manufacturing methods. So with this, now let us try to understand the working principle of 3D printing, or in short additive manufacturing. And if suppose you are planning to use this technology, right, what kind of steps you need to take to convert your idea into reality, and how can you put customization in the products? So that I will also highlight, right? So now let us start with the additive manufacturing. So as I told you that additive manufacturing is also known as 3D printing, right? And it is a process for making a 3D solid object by adding materials. So it is quite similar to the other manufacturing processes where we just start with the idea, then we try to convert that idea into reality. But here the working is totally different. Here we start with the zero, or you can say small amount of material is added on the base first. Then further we add multiple layers to get the desired geometry. So as per the ASTM International Committee F42, this method or this manufacturing, method can be defined as a process of joining materials to make objects from 3D model data. Model data usually layer upon layer, right? So the whole concept is that here we will make the object by just adding the materials in the form of layers. So stacking of layers, will be there to achieve the desired symmetry. And if I talk about the types of additive manufacturing, we can have different EM methods, right? For converting the idea into reality. So here, first one is the stereolithography, SLA. So this was the first 3D printing process, right? Among all the processes, this was the first 3D printing process. Okay, and it was invented around 1987, and this became very popular that time. So what is the working principle of SLA? Here we use the UV laser or UV light, right, as a energy source, or you can say as a curing mechanism. Curing means here a special kind of material is utilized that is deposited, or you can say here we have a tank or vat in which we fill the material in the liquid form, and that material basically is known as photosensitive material, photosensitive resin, or you can say photocurable resin. So what is the meaning of photocurable resin? It means that whenever we expose this resin under UV light, right? Under UV light, it is solidified. The nature of this material is like that. It is solidified under the exposure of UV light, right? Then second method is the SLS, or selective laser sintering. So here we use again laser, but it is not the UV laser, right? Here laser basically is high power lasers are used, but the laser is selectively, focused on the area where we want solidification, or we can say the sintering of the powder material. So the material form is the powder in this case. And third one is the fused deposition modeling. This process is very popular.
Dr. Narendra, I guess your screen is freezed. It's still on the very first slide.
Thank you for letting me know. Let me.
Yeah, now it's G.
No. Let me reshare my screen. Entire screen, rather, I would share with you. Now I think it is visible, ma'am.
Yes, sir. Now it's visible.
Please tell me.
Yes, AM technology is working.
It is getting changed now.
Yes. Additive.
Okay, thank you.
Okay.
So the third is the fused deposition modeling, in which we use material in the filament form, right? And this process is very popular. Why? Because it is very cost effective and very simple in nature, right? Because why it is cost effective? Because here we do not use any kind of laser, any kind of UV laser. Simple heater, right? Very small capsule heaters are available for 200 rupees, 300 rupees, right? So they are used basically here as a heating source. And if I talk about the filament, so the thermoplastic materials, which can be, which have the properties that are required in this particular process, they can be easily they can be easily converted into the filament. So these things make it cost effective. So due to these features, it offers accessibility to the user and versatility. Right? Another method, that is DLP, that is also very popular nowadays because of its hardware, right? It's very simple. So instead of UV laser, here what we use
Excuse me, sir.
Yeah.
Sir, your screen is not visible.
Ma'am, I have already shared, right? I don't know why it
Sir,
is not visible.
sir, it's visible. Yes, it's visible now, sir.
Now, ma'am, now it is visible
Yes,
or not?
it's visible. It's visible, sir, now.
I don't know. There may be some technical glitch, ma'am. I don't know because I
But
have not
could be,
done
sir,
anything
no
with
issues.
this.
No issues, sir.
So under digital light processing technique, here we use a projector, right? Which cures the liquid photopolymer. So SLA and DLV both are the same process, but in SLA what we use UV laser to cure the material. So UV laser means, suppose if the requirement is to make a 3D object, right? For every layer, the laser will move along along these rasters, and it will solidify the material. So whatever amount of material is in the contact with the laser, that will be solidified. But here at a time, in DLP, at a time, we are able to print a single layer because it is a projected beam, right? So again, it is similar, but here the difference is in the light source. So it enables the faster printing as compared to SLA. Then we have other methods like SLM, DMLS. So they are basically used to melt the powder material again, but we use them for metallic materials. Then we have some other additive manufacturing technologies like EBM, electron beam melting. So electron beam is again, it is quite similar to the laser beam. So by using this energy source, we can easily melt the materials and join them together in the form of layers. Then we have binder jetting. Binder jetting is again, here we deposit the binder from the top. Material is in the powder form, right? And we deposit binder selectively on the surface, right? Based on the data, whatever data we have received. Accordingly, what we do, we we just deposit binder from the top. For example, you have a Fevikwik, right? And you are depositing Fevikwik on the powder material, right? So due to Fevikwik, all the powder particles will be joined together. So it is like that, right? And laminate object manufacturing, here we use material in the paper form, and the material is in the solid form at the starting, and again a laser beam is used to cut the paper from the base material, right? Now here I have covered the working aspects of additive manufacturing. So there are three key steps. First one is slicing. What is slicing? Slicing basically is the extracting the contour on formation. Contour. Because what happens when we try to use any additive manufacturing method, right? We have to generate the layer information virtually in the software. Because we have to tell how many layers are there, what are the number of of the layer, right? So what we do, we virtually slice the object, because initially we make CAD model and then we cut this CAD model virtually in the software. So that cutting with the help of a plane and extracting that information, right? Contour information is known as slicing, right? Slicing. So the whole model is sliced into the horizontal layers. So once we get this information, what we do, we go for the toolpath generation, because toolpath is required. For example, if we are having a laser beam source method like SLS, again we have to generate the toolpath for laser movement. Similarly, if we have a FDM process in which we have a nozzle that moves along the different directions, right, to deposit the material. So we have to define the toolpath for nozzle movement. So in each and every additive manufacturing, we have to slice the object to generate the layered information, right? Then next part is the next step, or you can say that this is also another aspect of additive manufacturing, support. So if you look at this picture, right, this L-shaped object, here what we have done, we have flipped the direction of this object. In the first one, right, let me take this pen from here. If you see the direction of this L object, so it is oriented in this way only. But in the second case, it is oriented in this way. So, or you can say we have flipped the direction of this object, right? Now, what will happen due to this flipping? We have to generate the support material, right? Because of this overhang. Because underneath of this feature, we have the model which is having very low cross-sectional area. So wherever these kind of situations, are there in the model, the 3D printing softwares generate the support. It is quite similar to the scaffolding which we generally, do during the roof construction, right? So what scaffolding does for us? It support the construction related material, right? So once it is cured, later on we remove that scaffolding. Okay. So similar to that here also, once the printing is done, we remove this support structure from the part. Okay. Then another aspect is the fill. Fill means filling by material. Okay. So here what we do, we use material in the either in the powder form, liquid form, or solid form. So depending on the availability of additive manufacturing system, you can fill this particular space by using different types of material. Okay, compatible material. Now the question is, what are the differences between the additive manufacturing and subtractive manufacturing? Subtractive manufacturing, right? So subtractive means, what is subtractive manufacturing? Can anybody explain from the audience? Those who are from mechanical engineering background, I think they can explain about the subtractive manufacturing. They can correlate, right? Anybody from the audience, if you want to explain about the subtractive manufacturing, you may please unmute yourself. Nobody? Okay. See, subtractive manufacturing, basically we all are familiar with the subtractive manufacturing. Subtractive manufacturing is a process where we get the desired geometry by subtracting the material from the base material in the form of chips. So for example, if I take an example of lathe machine, what we do? We initially take a feedstock, right? We mount that feedstock on the lathe machine with the help of 3-jaw chuck or 4-jaw chuck. Then we rotate that workpiece at some speed, and with the help of a cutting tool, we remove the material as per the given dimensions. So in the subtractive manufacturing, what we do? We get the geometry by subtracting the material from the feedstock. Okay. So generally it is done in the form of chips. But when I talk about the additive manufacturing, it is a process where we add layers, we add material. That's why it is known as additive manufacturing. Right? So here I have highlighted some few differences between the additive manufacturing and subtractive manufacturing processes. So already fundamentals of 3D printing or additive manufacturing I have already shared with you. So if I talk about the additive manufacturing, it all about the adding individual layers of materials. But in subtractive manufacturing, we remove materials, right, to get the desired shape. And if I talk about the this complexity with additive manufacturing, as a complexity, as I already discussed with you, that level of complexity is increasing day by day. So obviously, these requirement make additive manufacturing is one of the key pillar of Industry 4.0 because it is capable to create highly complex geometries that are impossible using other methods. So what are the other methods? Like subtractive manufacturing, formative manufacturing. But in case of subtractive manufacturing, complexity is very limited, right? Because of the many reasons like tool size, tool height, right? And some of the position where tool is not able to reach due to the constraints. And third is the internal channels and holes in places that would be unreachable by other machines. So we can easily make them with the help of additive manufacturing. And another advantage with this method is that we can make assembly in a piece. So what does it mean? It means that if suppose we have a product where there are multiple components, right? We can fabricate them in combined manner, or in short, as assembly. As assembly, right? As assembly, we can easily make them. So this is one of the, I think, key features which make it more suitable for Industry 4.0. But all good things have some of the bad things. So apart from these advantages, we have few disadvantages, or we can say limitations, right? So first is the rough surface, because we generally make products or objects by adding material. So obviously this lead to the rough surface. Outer surface is quite rough. And sometimes it requires post-processing. If suppose we want to use that printed component in some of the application, it sometimes it may need the post-processing, right? Another limitation is the porosity. Porosity means because that is inherent. Let me check some other. However, if I talk about the complexity in the case of the subtractive manufacturing, it is limited. And accuracy also, depend on the tool diameter and resolution of the orthogonal axes. And if I talk about the accuracy in the case of additive manufacturing, resolution is too good in the X and Y direction because we are depositing material along the X and Y. However, we are adding layers, right, along the Z direction. So whenever we compare the resolution in X, Y and Z direction, always we will have the better resolution along X, Y directions, right? Compared to the Z direction. So due to porosity, we have anisotropy. So that is inherent. We cannot do anything. We cannot do anything, right? To just improve the anisotropy. However, in the case of subtractive manufacturing, the material is quite homogeneous, and the properties of the print or the fabricated specimens are quite predictable. We can make some models. We can easily predict them because we remove the material from the upper surface. So material is quite solid and very homogeneous in nature. And the thing that is make additive manufacturing winner in the comparison of this subtractive manufacturing. Here, EM technology can be used to produce a part in a single stage. However, if I talk about even the CNC, it requires considerable setup and process planning because considering the geometry that is under consideration, we have to make the tools, we have to design the fixtures, right? It requires a lot of time and also the cost involved there. But if you see the additive manufacturing, it is quite easy. If you look at this shape, cup shape, this is not even though very easy to make with the help of CNC or subtractive manufacturing because it is not that much complex, but it is having the curvature. It is having the sharp internal features which cannot be machined without a tool radius. And the cavity of the cup, sometimes it may be too deep to machine. Base cannot be machined, because it is the tool cannot move there, right? And also tool cannot change its position because fixtures are there. So due to the fixtures presents, we cannot machine the base. Okay. And sometimes some undercuts are required, which cannot be machined with 3-axis machining center only. So considering these facts, we can say that AM is having the capabilities to fabricate the complex shapes because it does not deal with these things. It does not deal with the, the tool radius. It does not deal with the fixtures or tooling, right? So we can achieve the, complex geometries with the additive manufacturing with each. And if you talk about the programming, in the case of additive manufacturing, programming is less complex. If you have any error in the program, right, it will only affect the part quality or part failure may be there. But if you do any mistake in the CNC programming, for example, let us take an example of a CNC machining center, vertical milling. If you, change any program sequence by mistake, it may cause serious damages. Why? Because tool may collide with the other components of the machine. Okay. Tool may collide with the other components of the machine. So due to these things, the programming is quite difficult. And whenever we write program for the CNC, we have to be very careful. This is a generalized additive manufacturing process chain, right? So here we start with the CAD model. We convert the CAD model into STL file. Do you know what is STL file? STL. If you're listening to me, please interact. Otherwise, it will be one-way lecture only.
Sir, it is stereolithographic file.
Okay. Any other participant who would like to add something about the STL file? Okay, very good. So CAD basically stands for the computer aided design file. Okay. So we can use other software to create the CAD model. STL basically stands for the standard triangulation language. Earlier, it was known as stereolithography file. But now, why it was known as stereolithography file? Because stereolithography was first additive manufacturing process. I have already told you in my second slide, right? Stereolithography was first process. Okay, so people developed a file for that process only. So that's why people used to call that file as a stereolithography file or format. But now what happened? Or what is happening basically? We have other additive manufacturing processes as well, in which we are using the same file. Okay, same format. If I talk about the FDM, we are using a STL file. If I talk about any other process, in which also we are using a STL file. So if we again call it stereolithography file, it will not be justice, or most of the users used with this. So that's why now people have changed, or the research community have changed the name of this, or the abbreviation of the STL to standard triangulation language. Why standard triangulation language? That I will cover in the next slides. Okay. So once we convert it into STL, we process it, we slice it, we generate toolpath, then we transfer file to machine. So whatever machine setup you have, you can just load the file on that machine only. So after loading, we do machine setup, depending on the the profile that is under consideration. So sometimes you can have the need to increase the temperature up to 250 degrees centigrade, or sometimes you need to maintain the temperature at 200 degrees centigrade. So then we set up the machine. But nowadays, what is happening? Recently I have purchased one 3D printer in my lab, where machines are smart enough, right? Once you load the file, they automatically detect the code, and they read the code and automatically take the decision. But earlier, we had to do the maintenance of the bad, or we need to leveling. Bad leveling is very important parameter in the past, but nowadays machines are having the sensors which automatically read the the coordinates, and they take decision by their own. So the machine setup, I think it has been most of the steps has been eliminated now. Then we go for the build, right? After building, as I told you, if any support structures are there, we have to remove those support structures from the part. And finally, if suppose processing is required, sometimes we need to improve the surface finish, dimensional accuracy, or the appearance of the printed object. In that case, we have to go for the post processing. Then if you think that the part can be used in some of the application, we can go for that. So in my case, we have modeled the cup. We have converted cup into STL file. Then we have generated toolpath for STL file. Sorry, this cup. And finally, we have poured the tea in the cup, right, to show its application. So what is CAD? 3D CAD modeling basically is a general prerequisite. Okay. And according to me, CAD modeling part is the most time consuming, step of entire process chain of additive manufacturing. Because formatting, like suppose if I want to convert CAD model into the STL file, it takes only few seconds. Similarly, part fabrication also takes around 1 hour, 2 hour, or 3 hour, right? But when I talk about the CAD modeling, it is a bit difficult, and for complex geometries, right? If your core CAD model is good, then obviously you will get the good printed part. But you are having the fault in your CAD model, then it will be wastage of time, because machine will take instruction from the CAD model only. So please ensure, if you are planning to work in the area of additive manufacturing, first you ensure the accuracy of CAD model. If it is having the errors, it is having the some missing features, obviously those features will not be printed by the machine. So give more time on the CAD modeling, right? And one more thing that I want to share with you based on my experience. Before printing, or sorry, before CAD modeling, right? Know the capabilities of your 3D printing system. Suppose if you have FFF or FDM process with you, first you check the manual of that machine and try to see the capabilities of that machine, try to see the constraint of that machine, right? What are the features which can be printed or cannot be printed? Then only go for the CAD modeling. Otherwise, what will happen? You have your CAD model is very accurate and having good accuracy and having all the features, but your machine may not have the capabilities to print those features. For example, here we have a printed model, right, of a bone. So this is, I think, quite complex. It is having curvature. Now, what will happen? If you check this model, right, there are many features. We have small holes. We have, some bend. Okay. We have the, variation in the size of the components. So if you look at this particular image, you will find the importance of CAD modeling. If suppose you are not able to make your model accurately, obviously you will not be able to print the object accurately. Okay. And this is the STL file, right? What is STL? STL is a piecewise triangulation or piecewise approximation of a CAD model. Piecewise, again I'm repeating, piecewise approximation of the CAD model. Why I'm highlighting this approximation word? Because STL does not carry the accurate information. Like, for example, if you have modeled a object with, for example, 50 mm, 50 mm, and we have a diameter, right, or we are having a hole in the center that is again having the variation in the size, or some curved hole is there, right? So when we convert that object into STL, what may happen? It will approximately capture the surface, because approximation depends on the size of the triangle. Smaller triangles will capture the surface more accurately. So wherever we have the curvature, right, on that place we will use the small triangles to approximate the surface. Again, approximation, because some data is lost in the conversion. Some data is lost whenever we convert the CAD model into STL file. So this is, I think, very interesting to know, because we think we have developed a CAD model and now we are going for printing, and if you check the dimension, you will find the difference. But first difference you will find in the STL conversion. Then after printing again, you will find the difference in the size because of the shrinkage, because of the behavior of the material, because of many factors. So obviously there are two steps which are very, very important when we deal with the this 3D printing. First is STL conversion. So try to approximate the surfaces of the CAD model with the help of small triangles, okay, to ensure the accuracy of the CAD model or the data. And during printing you have to maintain all the process parameters as per the material. Then only you can get the better accuracy. Now the question is, why STL file? Why STL? Why not other not other formats. Why these other formats are not considered? Because STL has the in STL actually we do the approximation of the surfaces by using triangles, right? And triangle is a polygon with minimum number of sides. So what is the advantage with this? It makes calculation simpler. Calculation is what calculation? Because I already discussed with you that slicing is the integral step of your this method. So whenever we talk about the the slicing, we need to do it virtually. Okay. So STL is having the triangle. So all sides, 3 lines we join together to create the triangle. So whenever we take the intersection of plane and the lines, it makes calculation simpler and it makes slicing easy. Okay. And selection of orientation is sometimes is very important, right? In 3D printing, it is very important to select the correct orientation. So in this slide, we have two cases, right? We have tensile specimens of two types. In the first case, we have a dumbbell shape. And the second case, we have the specimen shape as per the STM standard for polymers. And first one is used for the metals, right? Or steel. So if you look at this, if we can make this part in different orientation. Orientation basically defines the position of the object with respect to the X, Y, and Z direction. So we can orient this component either in this way, first way, or we can incline it at some degree, right? Angle, or we can keep it, vertical, or as per your requirement or your, wisdom, you can take decision, you can orient the part in any direction. So this is very important. What is your objective behind 3D printing? That should be clear while you are selecting the orientation. What is your, application? If suppose my application is to use the printed specimen for, somewhere where we need more strength in the specimen. In that case, I will choose different orientation. In the third case, here in this third case, the strength will be minimum if I stretch this specimen along the Z direction, right? Why? Because it has multiple layers. So it will weaken the part along the Z direction. But if I talk about this first one, here we will have the maximum strength because all the fibers, all the material are oriented along the loading direction. And we will have the maximum strength in this case. Second thing is that if I talk about the surface finish, third orientation will be perfect, right? Because in the third case, we will get the more better surface finish, and poor surface finish will be in the first case also and the second case also. Right? So similar conclusion you can get from the second type of specimen. In this also, we have oriented the specimen along the X direction, along the Y direction, it is flat. And in the third case, in the Z direction, it is upright. So as I told you, we can take decision by your own, depending depending on the factors which I already discussed with you. Now, let me also talk about the support structures. So wherever we have this overhang, right? If it is less than 45 degree, then no support structure is needed. When it is greater than 45 degree from the vertical axis, right? Then it needs support material. So this is not desirable at all because it increases the time, build time, and also it affect the surface. Wherever we add support structures, right? They ruin the surface of the object. So always try to build the part in such orientation where we get the good surface finish or the minimum support. In the case of Y, there is no support, but in the case of H, we have the support structure. In the case of T, we have support on the both sides. So these schematic you can see in the printed object as well. So later on, we can remove the support from the printed objects. So if you don't add the support, what happens? So you can see the consequences. In the first case, we have not added any support structure, right? And the second case, we have added the support structure. So with support, you can get the accuracy in the dimension, or you can be able to print the specimen as per your design. But if you don't add support, these situations may be occurred, right? Similarly, support type you can decide based on your requirement. So here, if you see the second image where we have the support structures in both the cases. So in the first case, we have used different support. In the second case, we have used different support. So in the second case, we have selected we have decided to print the object with tree support structure. So tree means it has branches and it will have the point contact only with the base surface, right? So it will be very easy to remove, right, from the surface, and it will also not affect the surface in the badly manner. But in the first case, because it is having the more contact with the this with this with the surface object surface, so it will affect that sorry, it will affect the uh, surface finish of the object. So you can decide, you can take your call on the support selection, right? Those who are not familiar with the 3D printing, they can start learning by just downloading the small softwares. You can import the STL file. You can also do a lot of things. So slicing, it is a process of generating 2D cross section layer from 3D model, right? As I told you, because virtually we have to cut the model into the multiple layers. So slicing basically is nothing but the process to extract the contour or profile information at various Z heights. So here I have taken the example of a cube, how we get the slice data or how we perform slicing in the softwares, right? So this is a cube, right, which has 6 faces, 12 triangles we have used so far to approximate the surfaces of the cube. And we have taken a plane which is intersected with the this cube at some height. So at that particular height, now we have received some information, coordinates. So after joining all the coordinates, we get the contour information. So this is how is STL is useful in the slicing process that I have shown here, right? So how a triangle can be intersected with the plane, right, to get the contour information. So this is the information that we have obtained from the slicing. Okay, one more parameter that is very important, that is layer thickness, right? Layer thickness, that is layer thickness. So here in the layer thickness, what we do? It is very important, process parameter, because number of layers, right, to make the object, that number will be decided based on this layer thickness value. So if the layer thickness is 1 mm and the size of the height of the specimen is 20 mm, only 20 layers will be required, right? But suppose if I reduce the layer thickness to 0.2 mm and again the height is same, so obviously 0.2, 0.2, 0.2, 5 times. So now layer will be increased to 100. Earlier it was 20 only, but now it became the 100. So you can see the importance of layer thickness, right? And if you increase the size of the layer thickness, this will also affect the surface finish. So that you can see in these two images where I have taken layer thickness of 1.3 mm. In the second case, layer thickness is 0.5 mm. So you can see the size of the stairs, right? In the second case, the stair size is very small. But here in the first case, the stair size is too big. So this effect is known as the staircase effect. So lower layer thickness gives the smooth surface and good dimensional accuracy. Sorry. So you can see the effects of building the objects with different layer thicknesses. Sorry. So you can see again the cup model that I have taken from the Gyan Gibson book of additive manufacturing. So here you can see that how layer thickness may affect the finish. Cusp error basically is the difference between the STL surface and the manufactured surface, right? Then we do go for the C code generation. So this code basically belongs to the triple F or FDM process, where we write a simple G code similar to CNC machining. So this is the code. Different patterns can be used to print the specimen. So rectilinear pattern, you can take some time. Line pattern, Hilbert pattern. Nowadays, some other patterns are also available, right, in the softwares. So you can explore. Any space filling curve can be used to develop the layer. So honeycomb pattern, if you think honeycomb pattern is too good for your case, you can select. If you think the concentric pattern is good for your case, you can select. So, but the popular one is the rectilinear, right? Raster pattern. The first one is more popular. Then we transfer the file to machine, right? Then we do machine setup. Okay, but this nowadays, as I told you, day by day machines are getting smarter, because that is the need of the industry 4.0. Machines should be able to communicate with each other. Suppose there are multiple machines in the on the shop floor, right, in the company or in the factory. They should be able to communicate with each other. Then only the industry 4.0 objectives can be achieved. Or machines should be able to take the decisions. Suppose there is a print failure, right? Or there is some problem during the printing. Machine should inform to the user, because recently the machine which we have purchased from Bamboo Lab company, so that machine has the feature that if any problem is there, immediately one message flashed in their software, right? Okay, this is the problem with the machine. You please rectify it. Otherwise, part failure will be there. So this setting up or these material feeding is not that much required nowadays, because machines are getting smarter and they have very good sensors. They can sense the situation. They can alert you. So those things can be uh, embedded with the existing setups or existing machines to make them smarter. Okay. So this is the video where you will see that uh, build building process or the printing process, right? So let me play this video for you. Okay, so this was the video in which you have seen the working of a 3D printing, a generic 3D printing process, right? So how we can deposit material on the build platform, how can we just uh, join them together. Okay, so then post processing, I have already talked about the support. So that support can be removed later on, right? We can apply some methods to improve the surface finish as well. Then we can go for the application part, right? Priming, painting sometimes are needed, right? For the acceptable surface texture and finish. Here now I will cover the application areas of 3D printing where you can apply, you can think about the use of 3D printing. So we can use 3D printing in many ways. You can use this process in design, in the engineering analysis and planning, in the manufacturing and tooling also, right? So there are many areas where you can apply the 3D printing, right? Industries like aerospace industries are benefited with this. Jewelry industries where you can design some unique ornaments. Consumer electronics nowadays it is very burning area where 3D printing is finding its place, right? So in the conductive tracks PCB, I'm also doing one project with ISRO where we are exploring the electronic application of 3D printing, right? We have got fund from there also. And biomedical is, I think, is the most benefited area, right? Where 3D printing has done magic. Okay. And some applications, just I'm going to show you. You can make some models, you can recreate the things, you can touch and feel the things by using 3D printing. You can check form, fit, and function of the components of the objects, right? So then you can also validate your invention. If you have suppose done something or you have invented something, you can just make the prototype. You can check its functionality, whether it is working properly or not, or as per your hypothesis, it is working or not. So those things you can do it. Patterns you can make for casting, because up to 10 years back, for example, that time we all were using the pattern of wood, right? But now it is not needed anymore. You can use patterns printed using this 3D printing method, right? This facilitated this particular thing. So casting, with casting you can make such kind of objects. Jewelry, again investment casting, through investment casting you can make this kind of jewelries. Directly you can wear the objects, 3D printed objects, handcrafted jewelry you can make, right? So these are some of the examples. Application of AM, direct tooling, direct tools you can make, you can directly make mold, right? Die, which is needed in the case of injection molding and other manufacturing processes. Reverse engineering. Reverse engineering can be done with the help of 3D printing. You can recreate the object by just scanning it, and then you can redevelop it with the help of 3D printing. Medical industry, where you can make the devices, right? Medical related devices. You can make some interbody fusion devices, right? And you can make the multicolor anatomical models, okay, for training purpose, to just train the doctor in the in better way, because if the doctors are trained, right, they will do best, right, for their patients. So for training purpose also we can use them. We can use it for the scaffolding, right, for the this the disabled people. This can help. So it can also replace the plaster, okay. It can be used in the dental applications. So some of the other examples, right, here are related to the 3D printing. And here customization, that we are focusing, right? Our focus is on the customization in the industry 4.0. So customization is easy, right? So such examples you can see here. Aerospace, because weight is the major concern in the aerospace applications. We can reduce the weight of the components without affecting its original strength of the part, right? Part strength. So we can fabricate lighter parts. So here I have taken some of the case studies where the NASA and other companies like GM, they have explored additive manufacturing to develop some lightweight components without affecting the strength, right? And here also you can make the tiny 3D printed satellites, right? NASA is also using in the International Space Station with the name of NASA Refabricator. So they have developed a special 3D printer that works in the zero gravity, right? So that works on the International Space Station. So 3D printing, you can say, it is the first manufacturing process which is being used in the space, right? Sorry. So made in space, basically under the made in space program, they have developed this printer, and so we have some application of additive manufacturing in the automobile. So you can create again fixtures, you can make components directly, you can make molds, right? Defense applications we can use to make the drones, right? Some respirator, multi-material respirator you can make for the army personnel. Food printing is, I think, one of the key area where you can explore this, because in near future you will have the, some other shapes of pizza and the, some other items, food items, they will have the different shapes, unique shapes. Because currently pizza is, having the circular shape only, but in the future it may have the, and similarly in the cake manufacturing, right, through 3D printing. So food printing, I think, one of the area where people are exploring it, how it can be used with 3D printing. Sports industry where we can explore this. So slowly when make customized soles for the, sports person. Adidas basically is using this technology, right? Right, you can order the customized shoes for you, and they will make it for you using 3D printing. Construction, I think, is also one of the, area where we can make the homes for the poor people, right, within the quick time. So here in India, one of the company, Tavasta, they are doing very good in this area, and they have done a lot of projects. And recently, I think IT Guwahati, they have also started another startup in this area. They are also doing good. So in this, they can, make the concrete formworks, right? And later on, they can assemble it. So you can also explore this area, right? This is very good. Here in this image, we have this 3D printed house. Okay. So that they have printed in a day only for only rupees $10,000. Okay. So challenges, if I talk about the challenges, current challenges, material limitations are there. We have to, do a lot of work in this area where you have to develop some suitable material, compatible materials for some specific applications, like electronics. Still, we are not able to make the most of the electronic components due to the material limitations. Material means we need to ensure the dielectric constant. Okay, we have to ensure the conductivity. So there are many issues, right, which are available in this area. Okay, so a lot work is needed to do. So first one is the material limitation. That is the second one is quality control. Consistency is not there in the parts. So that's why the data manufacturing process is not reliable that much. Because I have already focused on the porosity, right? So due to porosity inherent in the 3D printing, post processing and finishing is required, right? This is another challenge. That's why now the companies are coming up with the hybrid manufacturing methods. So now we are also going to purchase one hybrid additive subtractive manufacturing setup in our institute. So that will help us to post process the 3D printed components on the same setup, right? Then interaction property also one of the challenge, because anybody can replicate anything with the help of 3D printing. So it's very concern related to the unauthorized application and distribution of the designs. Because 3D printing has those capabilities. If you share your design with anyone, they can make their own. They can claim this is my design, right? Modification in the hardware and software in order to make it suitable for Industry 4.0. We have to modify the hardware. We have to add more sensor. We have to equip the machine with the good hardware and software. So those things modification will be needed in future to make them suitable for Industry 4.0. So future trends and outlook, again, hybrid manufacturing, more focus will be on the efficiency and the speed of the machines, right? And scaling and installation will be in the consideration, and you will see the advancements in the materials in near future, right? So more materials will be available for the processes, and with this I think I'm done from my side, right? So now let me take the queries. I think you have posted in the chat box. So let me check it. So if you have any query, right, you can ask, or if you want to discuss anything with me, you can again ask, right? Let me check the chat box.
Hello. Hello.
I think one participant is asking about the not clear about CNC and AM. Shivam, many, right? Shivam, CNC basically I have used here for the CNC machining center. Right? CNC machining means, for example, it may be CNC vertical machine, it may be CNC, the vertical milling center, it may be the CNC lathe, right? And additive manufacturing I have used here as a 3D printing process. So now I think you can get, the context of my lecture. Okay. In that I have talk about the differences between CNC and additive manufacturing. So
Hello.
still if it is clear, please let me know. I will explain you more. Okay.
Sir, I have one query.
Yeah.
Sir, should we integrate CAD within the machine, or it should be separated only?
Why do you want to integrate the CAD with the machine? What is the purpose?
So that the more automated work can be achieved, as we put the material and we can design the desired object.
So ma'am, there is a facility, we have connectors, right?
Mm.
So you can connect your PC with the machine. That facility is available nowadays also.
Okay.
That in that way people are doing integration, because we cannot add the PC or the personal computer directly on the machine. They are giving, providing option to connect your computer with the machine with the help of simple by just simple method, that is only simple cable, USB cable, right? So you can connect, you can do it. This is possible also.
Okay, sir.
Okay.
Sir, second query is, can't we design any object without support? By taking into consideration accurate coordinates.
But let me tell you, in that case, you have to increase the number of axes.
Yes.
Like, for example, suppose, because I have taken the example of a T, right? T example, T shape. So in T shape, we had the overhang on the both side, right? So when we print that shape with the 3-axis 3D printing system, in that case, we have to add the support structure, right? But if we have greater number of axes with you, what you can do, you can make the center part first, and then you can rotate the workpiece by 90 degree.
Okay.
So in that case, support requirement will be eliminated.
Okay.
And
Suppose
second method is,
we
one
have
more method is there, ma'am. So let me add one more thing.
Yes,
if you go for SLS, right? SLS means selective laser sintering.
Yes, sir.
In selective laser sintering, unsintered powder acts as a support material. So in that case, no separate structure is required as a support.
Okay.
The unsintered material will act as a support, because only wherever the laser will go up, that part will be sintered only. That will be solidified.
Okay.
The remaining portion on the bed, that will be unsintered position. So that will act as a support for your overhang features.
सर वैसे लास्ट में आपने बता ही दिया कि हमारे कुछ कंस्ट्रेंट्स हैं अभी मटेरियल की वजह से, तो मेरा भी एक है क्योंकि मेरा मटेरियल साइंस में ही काम है, तो टेम्परेचर इज क्वाइट बिग कंस्ट्रेंट इफ वी आर डीलिंग विद ए बायोमटेरियल नेचुरल मटेरियल.
Temperature means what temperature? Build temperature, build platform temperature or the print temperature? What temperature?
I think print temperature.
Okay.
Because if my material is protein based, so I can't increase the temperature beyond 55.
Yes. So in that case, you can go for other methods like you can find other mechanisms. Do not use the heating mechanism in that case. Like in my case, in one of my case, I have used UV mechanism to cure the material, right? But I think For your protein-based material, you have to check the literature whether any other mechanism can be used or not. So you have to be very careful in that. Okay.
Okay.
Satvinder Singh ji
Okay.
is,
Thank
I
you so
think,
much, sir. Thank you.
Thank you. If you need still any, if you have any query further, I will definitely help you. You can connect with me later on. Okay, through email. I will share my
Okay.
email ID in the chat box. So later on you can send.
Sure, sir.
your
Sure.
information.
Sure.
Okay.
Okay. Thank you so much.
Okay, welcome. And one more query is there, I think, from the Satvinder Singh. Satvinder ji, can you unmute yourself? Because I'm not getting your query. You are asking, is there any difference between layer distance and layer thickness? Because I have never heard about layer distance parameter. So can you please elaborate this particular difference, what you are asking? Because I don't know, I think I don't know whether any parameter is the layer distance. Layer distance, density is there, but infill density is there. Layer distance, I don't think any parameter. Standoff distance is there. So I'm not getting your question. What do you want to ask? No. Satvinder, I think I'm not clear with your question, so I cannot answer. Is there
Satvinder
anyone?
sir, Satvinder sir, please unmute yourself.
It's okay if you don't want to unmute yourself right now. You can send email to me. I will try to explain you there only. Is there any question from the audience?
Participants, if you have any doubt, you can ask from sir.
Because for you only, I'm in my office right now. If you're not asking or you're not listening my lecture, it's okay. ठीक है मैम फिर is there anything that is remaining? Please let me know. Otherwise, no question. Okay, thank you, Mukesh ji.
Thank you for the informative session, sir.
Thank you so much. So if you want to, anyone
Thank
of
you,
you
sir.
want to connect with me, I have additive manufacturing lab in my institute, right? Where I have procured many 3D printing systems, right? Recently, I have added, some of the 3D printing systems in my lab, okay, which are very powerful. And I have robotic arm. So I am working on the projects. And recently, one more thing that I want to add here, we have secured 2.5 crore rupees funding from DST to purchase the hybrid additive subtractive manufacturing. So that setup actually will enable us to print metallic parts as well as machining, right, on the same setup. So that will be available in our institute very soon in my department. So we are working in that direction also. So yeah, anytime you can visit, right? Nisi, I think he's asking about the visit. Yeah, anytime you can come, you can visit my lab or department. Okay, you can write
Okay.
your email
Thank
to
you,
me
sir.
regarding. I will help you.
Sure, sir.
Right?
Sure. Thank you, sir.
Okay,
Thank you so
So
much.
we will visit.
I
We will visit
certainly.
with our students.
Yeah, definitely, sir. Anytime. You just write email to me. I will take all the permissions from the administration, and then I will allow you.
Right, sir.
Okay.
Thank you so much, sir, for such an informative session. Thank you.
Thank you. Okay, thank you so much. Thank you again for your time and for invitation.
Thank you, sir. Thank you very much.
Thank you.
Thank you, sir, for joining us today. Thank you
sir.
so much
Thank you.
for providing us your with valuable time. Thank you.
Thank you. Thank you so much. Thank you. Thank you.
Thank you, participants. We'll meet tomorrow sharp at